Good morning, everyone. This is Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling Basic Electrical and Electronics Engineering. The subject code is W25301, the Regulation 2025. Today, we study the most fundamental semiconductor devices, such as PN junction diode. Almost every electronic device that we use today is mobile phone, computers, chargers, televisions, LED lamps, solar panels. It's all contains the diode, that is the PN junction diode. So it's very important because it forms the foundation for many other semiconductor devices such as transistors, LED, solar cells, so photodiodes. So PN junction diode is very important. The diodes is a common thing that it's very important. Today, we will discuss about the definition, what is the PN junction diode, and the introduction. So the formation of PN junction and the operating principle. So the current flow mechanism. Now, what is the mechanism of the current flow? Biasing conditions, applications, and uh, the summary of the final thoughts. So first, what is the definition of the PN junction diode? So the PN junction diode is formed when the P-type semiconductor and then N-type semiconductor. So it is joined together with the single crystal structure. So the boundary formed between these two regions is called the PN junction diode. So the understanding of P-type material is the P-type material semiconductor carries the majority of holes. So majority of holes and the minority of electrons. So for example, the silicon doped with boron, gallium doped with and semiconductors. So the understanding of N-type semiconductors, the majority carriers is the electron and the minority carriers is the holes. So the silicon doped with the phosphorus and the silicon doped with the arsenic. So the important point is the PN junction is the heart of the diode, uh, because of the all diode action occurs at the junction. So the next one is the introduction. So the pure silicon is not a very good conductor. So improve the conductivity. Impurities are added intentionally. So this process is called doping. So what is the type of the doping? It is a trivalent impurity. Next, what are the examples? Gallium, indium, boron. These are the examples. And the P-type semiconductor is because it creates the holes. So the pentavalent impurities such as the phosphorus, arsenic, and antimony. So the N-type semiconductor because it creates the free electrons. So the formation of the PN junction, this is the PN junction diode. That's the majority of this is the empty holes and this is the free electrons. In this between, if it always attract one on one, so it creates a depletion region. So the formation of the PN junction diode is to consider the silicon crystal. The one portion is doped with the trivalent impurity, that is the P region, and the another portion is doped with the pentavalent impurity, that is the N-type region. So when both regions are joined, it comes under the PN junction is formed. So the electrons are present, the large number in the N region, and the holes are present, large number in the P region. So due to concentration difference, the electrons start moving from N to P. So the holes start moving from P to N. So this movement is called diffusion. So what it happens, some electrons and holes recombine near the junction. So then it creates the here in this picture we have seen here the free electrons move towards the holes and the holes moves towards the electron. So it creates the region with no free charge carriers, that is the neutral particle. So it creates the region that is the depletion region. So next one is the diffusion and drift. Mm, in this also, we are having the charge carriers naturally move from the regions of higher concentration to the lower concentration. So the electron diffuse from N to P and the holes diffuse from P to N. So this is called the diffusion current. Then the drift current is also the fixed ion remains the junction. So these ion creates an electric field. So the electric field opposes the further diffusion. So due to this electric field, the charge carriers moves in the opposite direction. So this is called the drift current. So at equilibrium, the diffusion current is equal to drift current. So there is a net current is equals to zero. So next one is the operating states of the PN junction diode. It having the three conditions, that is the no bias condition, forward bias condition, and the reverse bias condition. The no bias condition is no external voltage is applied. If we don't apply the external voltage, then it's called the no bias operating state. And the forward bias is the positive voltage to the P side and the negative voltage to the N side. And the reverse bias is up the vice versa of the forward bias. That is the negative voltage to the P side and the positive voltage to the N side. Next one is the no bias condition. So in no bias condition, we having the no external voltage is connected. So the diffusion occurs initially, then the depletion layer forms. So the internal electric field develops. So the drift current is equals to diffusion current. At the net result, there is no net current flows. The diode remains in equilibrium state because there is a no bias condition. Next one is the forward bias, reverse bias condition. In the reverse bias, we are having in p-type semiconductor is linked to the negative terminal. So the negative terminal and of the power source, while the n-type semiconductor connected to the positive terminal. So under this setup, so the internal field to the junction and the external electric field applied to the battery is same direction. So it have the reinforcing the each other. So it having the reinforcing the each other. This is the diagram. There is no current flows, and it's a forward bias also having the same. The P side is a positive and the N side is the negative. The external voltage opposes the built-in electric field. So these are the diagram, and the application of the PN junction diode is we are having when reverse biased. In reverse bias, we have an external electric field and internal electric field act in the same direction. So the barrier potential increases and the depletion region widens. So the charge carriers cannot cross the junction. And the behavior is the depletion region becomes wider, the barrier potential increases. So the majority carriers are blocked. So only a tiny current flows. This current is called the reverse saturation current. So because of the minority carriers, the electron in the P region and the holes in the N region, so the reverse current is extremely small, typically measured in the microamperes. And for the breakdown region also, if the reverse voltage becomes very high, so the diode enters the breakdown. So the current suddenly increases. So it having the two types of breakdown, that is the Zener breakdown and avalanche breakdown. So we discussed in a future classes. Then the application of the PN junction diode is also having the rectifier. So what is meant by rectifier? It converts AC to DC, and it's always used in the you already know that used in mobile chargers, laptop adapters, power supplies, and the LED forward biased PN junction diode emits the light. So the application is also the traffic signal, indicator lamps, display boards, and the next one is a photodiode. The reverse bias diode sensitive to light, and its application is the optical communication and the automatic street lights. The next one is solar cell, which is used for the solar panels, solar calculators, solar street lamps. And the varactor diode is used in the radio tuning circuits and the communication system. So the important topic, the diode is act as a switch, and the forward bias, the switch on, the current flows, and the reverse bias, the switch off, the current blocked. This simple switching action in the bias for the modern electronics. So we have to conclude the PN junction diode is formed by joining the P-type layer and the N-type semiconductor is called PN junction diode, and it contains the depletion region, works based on the drift and diffusion of the charge carriers. So it operates under no bias condition, forward bias and reverse bias condition. These are the references. Thank you.